Okay, so finish the Hadoop 5 go at least. No, okay. Now next thing is the Spark. Okay, so uh, okay, have you everyone has started the Scala and or Python, right? First we have to go through Python. So I recommended some tutorial, right? Have you guys started that Python tutorial? The Python W3 school Python tutorial. This the basic fundamentals of the Pythons, right? Have you guys started or not this Python tutorial? I gave in the link before the holidays.
Not yet, Arvind. I will start from
Okay. Because yeah, Python is actually we are going to start the PySpark, so the Python should be based on. Okay. Okay, I will cover 3 days session for the Python first. Okay, then we'll start the Spark. Or let me do one thing. You start Python and I start this Spark concepts, right? Okay, because Spark is a theoretical concept first. So that is not a matter of language. Okay. So first 3 days you take time in the covering this entire things in the Python. Okay. I will do some Python coding exercise. Okay. Before that, I do the starting of the Spark, right? Basic fundamentals, so that you can start Python and Spark coding together. Okay, right. Okay. So when we are going to start the Spark, okay. So we know Spark is a replacement of MapReduce. Okay, we already done the MapReduce. So Spark is a replacement of MapReduce because MapReduce is a processing engine. Right? Processing engine of the Hadoop. Processing engine of Hadoop. Okay. So why it is replacement? The one thing is Spark is the Hadoop is Hadoop MapReduce, right? MapReduce is only only batch processing of the data, batch processing, only historical data analysis, history data analytics. Okay, any type of data, like it's a weather data or it's a cricket match data, right? History data, right? So whatever history data is there, any type of history data, we do the processing through the MapReduce, and it's completely Java. Okay, it is a Java and Python. There are two options: Java and Python program we can write in the MapReduce. Okay, but Spark is not only batch processing; it is giving real-time streaming. Okay, right? So batch processing and streaming data processing. Streaming data processing, we can say real-time data. Okay, real-time data. So real-time data processing we can do in Spark. Okay. So that's
in
a one.
memory.
Anybody is asking?
Yeah, it's with the in-memory processing, right? So that's why I'm saying.
Mhm. See, in-memory processing is used for both, for batch as well as real-time. So in-memory is like the internal concept of the Spark, right? Spark is an in-memory computation. So in-memory computation. Spark is a in-memory computation. So I will tell you what the major difference between the MapReduce and the Spark. So in MapReduce, this is the one thing is processing things, right? The difference is MapReduce only batch processing, Spark is batch and real-time streaming both. And another one is a MapReduce when intermediate output data is generated, when intermediate output data is generated, that will be stored in the disk only. That will be stored in disk, and again further processing, it will be it will be read from the disk, right? So it is basically more time processing, right? It is taking more time. It is taking more time to process data. So execution is not faster. Time taking more time to process data. So it is not faster. Okay. If I say Spark is using in-memory computation. So in-memory computation, the only requirement is the Spark is that it should have a very high configuration RAM. Okay. So data processing is happen. So intermediate output data. The intermediate output data is produced and stored in memory itself. Stored in memory for further processing. Further processing till final result. Till final result. Okay. So till final result. And after that, the final result will be stored in the disk. Okay. For permanent storage will be stored in disk. So Spark is the job is faster because it is saving the time. It is saving time to write and read again for further processing. So that is the reason Spark is faster, right? So 100 times faster in memory. So if your job is processing in the memory itself, so it is 100 times faster in memory and 10 times faster in the disk. So still it is faster than the MapReduce, 10 times faster. 10 times faster than MapReduce because MapReduce is a disk based, right? So 10 times faster in the disk. Okay. So this is the comparison between the MapReduce and the Spark. Okay. And first thing, what we have to understand in the Spark, okay, like Spark is having and multi-language. Like if I say here it's a multilingual, okay, multilingual, okay, like multilingual, like it's support Python, Java, Scala, and Spark is written in Scala language. So Spark is written in Scala. Like Hadoop is written in Java, Spark is written in Scala. Okay. The native language of the Spark is Scala. So if I say the jobs will be faster, in which APIs? Scala will be more faster. It will be more faster than the PySpark. More faster. Because it's a native language. Okay. So Python plus Spark combination called PySpark. Okay. And Scala with Spark combination. Combination means Spark code written in Scala API. Spark code written in Python API. Okay. Spark code written in Scala is Spark Scala. And Scala and Java plus Spark, like Spark API written in Java is Spark Java. Okay. And one more is a R language. So R plus Spark is a Spark R. Okay. So these are the various combinations are there. We can write our program in these different combinations, right? These different APIs we can use, right? So why we go then Python, why we go for Scala? So see, when we have application, when we have analytics, right? For moreover, data science, right? Data science and machine learning libraries, we go for PySpark because Python is a more oriented, like data science oriented programming language. So Python is more algorithm, machine learning, algorithm and machine learning, data science, algorithm, data science oriented. Data science oriented. So that is the reason PySpark is a good choice. PySpark is a good choice for this type of scenario. Okay. If I say my application is not more data science centric. My application is a more like analysis is like performance is the matter. Okay, when the performance of the application matter, performance of application is matter, like execution speed is matter. Then Spark Scala is a choice. Spark Scala is good choice. Another one is like if I say my libraries are, I want to use the R programming, right? So I have, if I want to use, if I want to use R programming language, R programming, then I can go Spark R. Okay. If I want to use more Java library APIs, if I want to use more Java programming, okay, APIs, like some third party Java libraries. So many Java libraries are there. So third party integrations, third party Java integrations. Okay. I want to do, then I will go with Spark Java. So generally companies Spark Java use when they are using some Spring Boot application, right? Some microservices application, they are using Spring Boot and Angular. Front-end, back-end application is there. Angular, Angular is a front-end application. Okay. So in that case, Java is a good choice because already Spring Boot is a Java. So when Spring Boot is a Java and I want to do analytics in any other different programming language, better than I will use the Spark Java. So I can integrate the Spring Boot application in the same application, Spark Java application. So then these are the combinations when we use. So mostly like these are the two different choices, right? Like either Spark Scala or PySpark. Okay. But other two are specific to the utilities you want to use, right? This Spark R and Spark Java. Okay. So Spark R and Spark Java is completely depend on the scenario, we can say. Okay. So when we come to the Spark modules, right? When I want to start the Spark, so Spark architecture. Okay, let's see first Spark architecture. Like we seen Hadoop architecture, right? Before that, Hadoop architecture, MapReduce architecture, Hive architecture. So every component having its architecture, right? So we know, right, every component having its own architecture. Like Hadoop architecture, when we talk about, we have SDFS plus MapReduce, right? So Hadoop architecture is a combination of SDFS and MapReduce, right? When I say SDFS architecture, so in that case, I will say SDFS architecture, I will say name node, data node. So storage component and processing component. Name node, data node, and secondary name. Okay. Secondary name node. Okay. When I say MapReduce architecture, I will talk about map and reduce function. Right. I will talk about map and reduce function and shuffle and sort, right? And shuffle and sort. Okay. Hive architecture, like we have Hive components are there. So different Hive components are there. Like Hive compiler is there, parser is there. So compiler, parser, okay, Hive metastore, Hive CLI is there, Hive script server is there, Hive beeline server, script server, so beeline server, okay, and Hive execution engine is there, Hive execution engine, which is executing query execution engine. So these all components make it architecture. So this is architecture, right? So when we come to the Spark also having a master slave architecture. So Spark has a one master, okay, and other are the worker node, okay. So master is a like a supervisor node, and other node is a, but Spark should be installed on each and every node, okay. Same like a Hadoop is installed on each and every node. So same in the Spark cluster. When I say Spark cluster, when I say Spark cluster, so Spark will be installed. So Spark will be installed on each and every master and worker node. Master and worker node. Okay. The difference is like master will be high configuration one, and worker will be their executors will be executing the task. So master will be where driver program is running, where driver program is running, driver program is running, which is a starting point of your Spark code, which is the starting point, starting point of Spark program. Okay. So driver program is running on the master, and workers having executors. So executors is a unit. Executor is a unit which is executing task. Okay. So everything is on the data node is happening. So internally, these workers are the basically data node, because complete Hadoop architecture, the Spark is on top of the Hadoop, right? So if I say Hadoop means HDFS, so Spark is using, actually Spark is the benefit is Spark having a different cluster manager. So Spark has different cluster manager. Okay. So what is this cluster manager? Cluster manager is what type of program you are running of the Spark. Okay. So either three cases are there. Okay. So you say, okay, I'm running my local program locally, like in my local machine, I'm running program without Hadoop. Okay. So that is called local cluster manager. Okay. So there is no need of Hadoop, no need of Hadoop, like storage part. Hadoop means, so whenever I'm talking about in Spark Hadoop, that means only I'm just talking about storage. I'm not talking about the MapReduce, because MapReduce is the Spark is the replacement of the MapReduce. Okay. So whenever I'm talking about storage, then I will talk about the Hadoop only in the Spark, because Spark will be using only storage part of Hadoop if it is required. Otherwise, if it is not required, it will not use. That is a local cluster manager. And second cluster manager is a yarn cluster manager. The yarn cluster manager is like Hadoop based cluster manager. So that is basically Hadoop based cluster manager. So when you want to use the storage of Hadoop, when we use Hadoop storage, then we go for this cluster manager, because your program will be running in the yarn cluster manager. Your program is running through the yarn cluster manager, and it will be using the storage part of Hadoop, right? Hadoop file system. So your input and output data will be same like MapReduce job we were running in the Hadoop as a storage. So same Spark will be using the Hadoop as a storage for input and output. Okay. And another cluster manager is Mesos. But Mesos is a separate cluster manager for the multi-processing or multi other purposes used. So Mesos is the cluster manager that is not part of yarn and local. It's a other type of distributed processing server. Distributed processing server. So similar to yarn, so there is another one is Mesos cluster manager. So what happened in the architecture when driver program? So driver program, when its program is like a Spark submit command is there. This Spark submit command is like you use Hadoop jar command, right? When you are submitting your MapReduce job, how you submit? Hadoop jar name, right? And you have class name, then input path and output path. Like this you gave in the MapReduce. This is for the MapReduce. But your same thing, like suppose you want to submit a Spark job, suppose you have a Scala code or Python. So for Scala code, when you are using a Spark Scala code, then you have a jar file is there, jar file of your classes, jar file of classes of your application. Okay, same like Java application we have, same Scala application also having the jar file. And and we are using build tool to create a jar. We are using build tool, either Maven, Gradle, or one more is a SBT. SBT is specific to Scala. So Maven, Gradle, or SBT, these are the build tool to create jar of application. Okay. But in case of Python, when we are using PySpark, in case of PySpark, there is no jar, so directly py file is there, main class. So main class py file, we will do the Spark submit on that. So Spark submit command we will do on Python main class file. Okay. And in case of Spark Java application, if application is Spark Java, same jar file of the classes, same thing. But here is SBT will not be there. It is the same thing. But in Spark Java is also having a jar of your classes, but there is no SBT. Only two option is there for Spark Java application. So what type of application we are using? We are defining the like how will you do the Spark submit. Okay. So Spark submit, like the driver class. So when we are having a driver program, right? So this driver program code, this driver program is nothing but your main class. So driver program is your main class. This main class could be a Java main class, or it could be a Scala main class. Like a Scala main class is an object. Scala main class is called object. Okay. And Python main class or Python main class. Okay. So all these main classes are called the driver. So when you submit a driver program, okay, then it calls, the driver program calls cluster manager. Cluster manager will be depend what type of cluster manager you have configured for your application. Okay. So if you are using a Yarn cluster manager, or you are using standalone. So this is the local, or means standalone. Standalone means local. So standalone or Yarn or Mesos. So mostly two are there in our case. We are not using the Mesos, standalone. So standalone or Yarn cluster manager will allocate tasks to the executors in worker node. Okay. And each executor in worker node will be executing tasks and stored in memory, right? Their internal cache memory there is stored in cache memory internally on same worker node for further processing. Okay. And finally, when processing is done, then output result is returned back to the cluster manager, and cluster manager will be returned back to the driver. Cluster manager will be returning back to driver, and driver will be giving output to the end user. So driver will be giving output to end user who has invoked the program. So I will show you the diagram so you can see how this Spark architecture looks like. The Spark architecture. If you see the Spark architecture, so you will see here like a Spark, there's a driver program, master node, worker node, so same thing, cache, and here is the executor. Actually, they have not shown executor. So here is the executor. If you see this one, so here you can see executor is there, executor. So driver program is connecting to cluster manager, and cluster manager allocating tasks to the executor. Executor is performing the task and storing cache. And once the all tasks done, then it is returning back to the cluster manager and finalization. So basically Spark context. Okay, and one more thing is this execution is within the Spark context is done. Okay, so in the Spark having a different versions. Okay, so Spark 1.x version, that is pretty old version, Spark 1.6. Okay, so there was a Spark context was there. Okay, Spark context is the entry point. So Spark context is the entry point to start the execution of your program. Execution of your program. Okay, and like it's a single entry point. The limitation was the Spark context. It's a single entry point. Like input and output point is a one single entry point. Okay, single entry point. But in Spark 2.x, they have given like Spark 2.x onward, and Spark current Spark version is a 3.x. Okay, we will use Spark 3.3 or Spark 3.2 or 3.4. There are many versions are there. So Spark 3.3 and 2.x has Spark session, and Spark session is a wrapper on top of the wrapper on top of Spark context. Okay, so what they did, they have created a Spark session on top of the Spark session, and this Spark session can be multiple sessions, right? A Spark session can be initiated. Spark session can be multiple in a one program. Okay, so here is the advantage, right? So multiple sessions can be created from one Spark session, right? Okay, but Spark context can be one. That was the limitation in the 1.x and 2.x, 3.x. They have given the Spark session, that is a wrapper. So whenever we start a program, right, when we write a code, either we need a Spark context or we need a Spark session. Okay, so mostly when we are using Spark 2.x and 3.x, so we use Spark session only. Okay, so Spark session variable name is, so Spark session variable name is a Spark. So when you will see in the Spark shell, okay, and one more thing is, we have a different way of the execution of the program. Okay, let's come one by one. Okay, so Spark program, right? How many ways we can write the program? Okay, first we see this. So Spark programs, right? Okay, so there are the Spark shell. That is the one way. Spark shell. So Spark shell, there are the two Spark shell are there. One is a Spark shell for the PySpark. So one is a PySpark shell. Same like a Hive shell is there, and Hive shell and HBase shell, right? So same like a PySpark shell is there. Okay, and this PySpark shell, and another one is we have Spark Scala shell. Okay. Okay. These two are the interactive shell. Okay, these two are interactive shell, and these two are shell where we can write one by one, line by line statement. Okay. Second way is we can use some IDE tool. Okay, so these are the two interactive shell. Okay. So in case of PySpark, you will see this operator like this. This is a PySpark shell. Okay. And Scala shell is like a Spark Scala shell is a Scala prompt will be there. So this is the Spark Scala shell. Scala prompt will be there. So prompt will be Scala like this. It is the Spark Scala shell, and triple greater than sign. This is a PySpark shell. Okay. Second way is we can use internet. This is IDE tool, integrated development environment. So integrated integrated development environment. So we have different IDE tools are there. So if you know about the Eclipse, like Java application is more popular, Java application. Okay. Even for Scala application, there is a Scala IDE is there. Scala ID. This is also Eclipse. Eclipse ID or Scala? Eclipse ID. Eclipse. So one more Eclipse is there for Scala. Okay. Eclipse ID is for Scala. Okay. So these are the two for Scala. Okay. And one more is IntelliJ. IntelliJ already you seen. I have already shown you the for Java. The same IntelliJ is used for Scala. Okay. So you can write a Spark Scala code. Spark Scala code you can write in the IntelliJ. And PyCharm is ID for the PySpark code. Okay. So these are the option for the ID. Okay. And the other third way, like this is a local environment, right? You cannot run this one is a cluster environment because this is just only because of the job. You are just testing your application. You know, right? MapReduce code we are able to run in the IntelliJ or we are able to run in the cluster. So when we are able to run in the cluster using the Hadoop jar command, so that is our cluster one. So same thing is when Spark program you are doing using a Spark submit, when you are doing using a Spark submit, like job submission you are doing on the Spark cluster, job submission on Spark cluster. Okay. So this is so this one is basically whatever program you created through Java application, through Eclipse or IntelliJ, so you will be doing the job submission here on the Spark cluster. Okay. So these are the different ways you can write a program. Okay. And now, like Spark is having how many modules are there? So Spark is having a base module. So Spark has total 5 modules. Okay. So out of 5, we will be using 3 only because 2 other are machine learning related and one is a graph. Okay. So that is not being used for the data engineer. Like any data engineer can use, but if it's the application is the machine learning application, so Spark ML Lib is used. So Spark core is the base. Spark core is a base module. Okay. And this module is basically used for code transformations and actions. So when we are talking about the ETL, so mostly major part is in this one only, right? Transformation part when we say ETL. So when we say we are writing a ETL code in the Spark, right? So the entire ETL code is written in Spark only, is written in Spark, but the major part of the transformation part, so extraction part plus transformation part and finally loading the data into target. Okay. So this transformation part is basically the Spark code. Next is the Spark SQL. So Spark SQL, the ETL pipeline, the two extraction and loading part, that is from the SQL. So Spark SQL is module which is reading and writing data to different data sources. These data sources can be anything. It could be a file system sources or target, file system, source and target. Okay. So file system source and targets means like CSV file, JSON file, XML file, Parquet file. You know all these format, ORC, Avro. Okay. So these are the different types of file format data or SQL data sources or target. So when I'm saying data sources and target, it could be a same thing. Okay. But difference is it could be a same source, same target type. Okay. Or it could be a different source and different target type. If I say my source is a CSV file, but my target is a SQL database, or my source is a SQL database, but my target is a Parquet file. Okay. So combination can be anything. Okay. So SQL data source and SQL SQL target, SQL data store target. Okay. So any SQL database come in this category. It could be MySQL, MySQL, Oracle, SQL Server, any database, or NoSQL source can be there. NoSQL source and target. So it could be Cassandra, MongoDB, and HBase. And this is the SQL. Next is a Spark streaming module. The third one. This is for real-time data. So whatever we are saying is Spark SQL, this is the batch processing. This is the batch processing. Okay. And when we are talking about the Spark streaming module, this is the real-time streaming. Okay. So this one is a real-time streaming. And when I say it is reading data and writing data to the streaming sources. Okay. So streaming source, what could be streaming source? So streaming sources, I say Kafka. Okay. So suppose I'm going to read the data from the REST API. So REST API, I'm getting the data. REST API or through Kafka, right? Kafka also is streaming source. So Kafka is a message broker tool. Okay, so that is also a streaming source. Okay. Anyone has any question so far? Anything?
I have a question, Arvind.
Hmm.
Basically, Spark written in Scala, and when
Mhm.
we are working with the PySpark, let's take an example here. So when we are writing the data, every I mean, let me go with it. Driver and worker nodes needs a JVM, right? Java Virtual Machine.
Yeah, because Java JVM is
Yeah, I mean
approximate
for the cluster. Yeah,
cluster.
let me continue. For the cluster management, we have to go with the Java Virtual Machines there, and why we are using Scala there? I mean, if we go with the Java, it will be more faster than Scala, right?
Okay. See, if I say this entire Spark is built on the Scala because the library,
Mhm.
everything is
Yeah,
Scala.
yeah,
So every call, like if you write a code in Python or if you write a code in Java, it will be definitely converted into a Scala, right? Because the end library is the end user library is the Scala, right? So
okay,
why we say Scala one is faster because the transform conversion will not be there, the code conversion, right? Like translation of the code, right? Okay. But still
yeah,
somebody choice is like my program, my requirement is more Python, data science, machine learning, right? So the PySpark, see, it's nothing much difference. But if the performance is a matter, then Scala is the best choice. Okay. If there is no machine learning APIs you want to use, so then we can go for the Scala. Okay. If it is a Python, Java, it's a all choice. It's a like a multilingual, right? There is no dependency. Like someone knows Java, he can write program in Spark in Java. He knows Scala, so he can write Scala. Someone knows Python, so it's a like a not a one particular language is not rely on. Okay. Yeah.
mm, yeah. Got that. And another question is, um, we have to when we work with the clusters. I mean, I worked on Databricks, so there is two kinds of clusters are there: all-purpose cluster and a job cluster. I mean, job compute one. So
Interactive cluster and the job cluster. Interactive shell is means notebook, right? You're writing a notebook, right? And the
uh,
job cluster is like you're writing entire program and you running as a job, right? The same thing is here also. So interactive shell, you say here this shell. These are your same here, okay? And when you write a program and do the Spark submit manually, that is your same like a job cluster. But Databricks is the ready-made environment, right? Like it's like a vendor, right? Because here you are installing Spark in Ubuntu, manually, right? And you are doing everything manually here. Even the job scheduling you want to do, you have to use some tool like Airflow, Uji, right? You have to use. But there is a
Okay.
inbuilt workflow is there, right?
Okay.
Mm.
Yeah, can we integrate Databricks there to the, I mean,
Databricks having itself
how do,
Spark. We don't need to integrate, right? Databricks means Spark itself, right?
I mean, when we are creating data pipelines, we have to process the data, right? So can we integrate Databricks to the, I mean, it's a
Ubuntu.
Ubuntu, yeah.
Databricks is a cloud base, first of all, okay?
Okay.
They have cloud base, either Azure, AWS, or GCP.
But
Any one
yeah,
of the cloud base, or separately also they have their own Databricks community version is there, right? Their own.
yeah, yeah.
But internally, that will be using also any cloud only. If you see, it will ask you which cloud you want to use a storage, because Databricks doesn't have its own cloud storage, correct? Okay. So
Yeah.
Databricks is a separate thing that is like similar to AWS EMR, okay, or you can say GCP data prop, right? Okay.
Okay.
So when you want to use some managed cluster, like you don't want to take uh, responsibility of managing the cluster, then definitely the companies go for the managed cluster like EMR or like Dataproc and the Databricks, right? So everything cluster perspective is handled by the that vendor, okay? But when we are using PySpark on Ubuntu, here we are learning for testing purpose, right? We are learning, right? Okay, because we cannot afford the cost, right? So cost we
Yeah.
cannot afford, right? We can do practice, but we will not get all the features of the Databricks, right? We can get the community version, but one time we do practice, that is fine, because we have to understand the Databricks cluster, but that is just 1 hour thing to understand the whole architecture of the Databricks notebook. It's not big deal. But whatever you learn in the PySpark shell or through IntelliJ, PyCharm ID, that learning is the real-time learning in the project, right? Okay, because development is needed first. Then after you will go to the any particular type of environment, right? Whether you go Databricks or you go to EMR or anything you can go. Okay, but the concept Spark will never change. Whatever you learn these modules, Spark Core, Spark SQL, Spark Streaming, it will never change there. Everyone is using the same concept.
Yeah, but we can see the processing and everything on a Spark UI, right? On a Databricks as well.
Yeah, Databricks I will show. I will show it. It is not first time just started the. It's the first session, right, to understand what is Spark.
Got it.
Many
I'm just
people they are first time just understanding this theoretical concept, right? So once they understand theoretical, right, what are the components are there in Spark? What is the Spark Summit? What is the ETL? What is the Spark Core? Then I
okay.
think everything will be easy, okay? Because these are the theoretical part, fundamentals, concept.
Yeah, got that. Thank you. And I mean, I listened to someone, so they said Kubernetes also they used as a cluster. So
One more cluster manager.
yeah.
Actually, I have not mentioned here. So the one more cluster manager is a container based. So Kubernetes is the type of cluster manager when we are using containerization. Okay.
Okay.
So when I'm just using the same Spark program, I'm not install manually the Spark. So I'm using a container based. Okay. So I can go for cluster manager as a Kubernetes. So the advantage of that cluster manager is like it will be completely lightweight and microservices based architecture. Okay. So benefits are there. Okay. So once we start the DevOps, right? The DevOps with the big data engineering component, there we can understand, like, okay, this cluster manager is one, Kubernetes is there. Okay. Yeah, Kubernetes cluster manager is there. If you want to go through the documentation, like here you can see. So So this all concept we need to know first, right? Docker images. So I don't want to like see this is just only master you will change. So instead of using our any worker node, we are using some containers, right? Some host, right? Where we have Kubernetes, right? Okay, so we are using Kubernetes type of, and we are using this is like containers images. So Spark, like we are whatever install we are installing the Spark manually, right? So that is also one image, right? Image is nothing but the complete package. You can take it from the repository and install it. So container is giving images, right? Like a repository. Repository is giving you the images, and once you bring this image to your local and run that image, it will become container. Okay. So container is a physical copy, and image is a logical copy. So when your image is in the repository like a Docker Hub repository or a Spark, AWS has ECR, Elastic Container Registry. So these are the repositories where the images are stored. And when you pull these images, bring it to your local and run this image, then it will become containers. So this containers like where we are running a Spark code. Okay. So I think like see if this is very high advanced level step, okay, we can understand and at least knowledge. If you get a chance to work on this Kubernetes environment, that is really good, and understanding concept is important. But first is what are the basic steps are needed, right? Like before going to the Kubernetes. So if you go through these things, RDD, structured streaming, Spark streaming, these are the first fundamental things, right, to enter into the Spark. Okay.
Yeah, thank you.
Okay.
Thank
So anyone else has any question? Okay.
Is the Spark architecture is same for a Spark streaming as well? I mean the driver and the worker node.
Yeah, that part is same. Only difference is like what type of task is allocating, right? Whether it's the streaming. So executor is having a knowledge of what type of task execution. Okay. Mm.
Yeah, okay.
Okay, so Spark having for the two more modules, Spark ML, Spark Graph. Okay. ML is used for machine learning libraries. So Spark having inbuilt machine learning libraries functions are there. So either you can use pure Python or you can use Spark ML, but you are using a Spark ML means Spark features you are using, Spark in-memory computation. So the Spark ML libraries libraries is using machine learning functions, machine learning algorithms with in-memory computation. Okay. So many projects using the Spark ML instead of using if they are using already Spark, so they prefer Spark ML. But this is very specific to the project, okay? Because if the project requirement is machine learning libraries, then they will use Spark ML, okay? And Spark Graph module is the module like it's a it's a graph, right? Like we can say vector and edges, right? Vertices, not vector, vertex. So vertex and edges, right? So like any graph we can form using the vertex and edges, right? So just some examples like some graph DB is there. I talked about in the NoSQL DB, right? NoSQL graph database. So graph database is a New4j. New4j. So similar way, this Spark graph is giving feature, like if like I don't have the 2D data, I have a graph form data. Okay, so I can easily manage with the graph. Okay. So this one is using like friends of friends likes. Okay, like Facebook. So you can understand the better example is Facebook. Like they have like every node is connected to each other through edges. Okay, so our main concentration is these three: core, SQL, and streaming. Okay, is core, SQL, streaming. These are the core part, right? Because these three are related to each other. Okay, so if I'm writing any ETL pipeline, so ETL pipeline will definitely use the core. Core will be definitely there, but Spark SQL and Spark streaming. So Spark SQL will also there, but Spark streaming is optional, right? It is depend on the whether we have real time streaming or not. If the real time streaming is there, if real time streaming or real time data processing is required, then this Spark streaming there. Otherwise, Spark Core plus Spark SQL will be there. Okay, so this is the modules, right? Next thing is what are the data structures are there in the Spark. So we know every language has the data structure, right? So we know, right, data structure, like some fundamental building blocks are there. That is data structure, right? So when I talk about the data structure, so every language is having data structure. Like if I say Java, Python, Scala, so they have collections. So different collections are there, right? So we have list is there, set is there, map is there. Okay, but in the Python, map is not there, so there is a dictionary is there. Dictionary is there, right? Different name is there, but altogether it is a same type of functionality, right? So map is also key value pair in Java, Scala, but dictionary is also key value pair in the Python key value pair. Okay, so but if I say Spark data structure, right? So Spark has three data structure. Okay, one is RDD. So everybody heard about the name RDD, resilient distributed data set. And second one is a data frame. And third one is a data set. So when I say RDD, RDD is basically a fundamental unit of the Spark, and it is immutable collection of data. It is immutable collection of data which is spread across the workers, executor, spread across workers, executors. Okay, and when we are doing any operation on RDD, when we are doing any operation means transformation. Any transformation on one RDD, it will create new RDD. It will create new RDD. It will not modify the RDD, because that's the reason I said RDD is the immutable. So when I say RDD has the three things: resilient, distributed data set. Okay, so when I say resilient, this is very important keyword in the RDD, the word resilient. Resilient means fault tolerant. So we know fault tolerant, Hadoop is completely fault tolerant, right? You know, data node, right? Master node, all are the fault tolerant. If data node is down, to another data node has the replica, right? So fault tolerant. Tolerant. So fault tolerant is basically if any like data is present, like it's a replicated data. So resilient means it's a fault tolerant RDD, and RDD is following the another concept is DAG. So DAG is very important concept, direct acyclic graph, direct acyclic graph. So here is all the transformation are stored in the form of DAG. Like if I say I have some input data set, input data, like some CSV file data, and this input data, I'm applying some transformation flat map. Okay, I will talk about what is this flat map. Okay, filter, very easy, understandable. Like we are filtering the data. Something I have A to G letters I have, but I want only A to C letter. Okay, so that kind of thing is filter. Okay, so filter. So like these transformations are there. So these transformations are forming a DAG. Okay. If any point your like your any operation got failed, so it will not recompute from the scratch because it is separate RDD. This is stored as a, when the data is read as a CSV, it is RDD. Again, another RDD is created here. Another new RDD is created here. Another new RDD is created here. So whenever any operation got failed, so it will not recompute from the scratch. Okay. So that is the benefit of the DAG, right? So it will not, so that is the reason, like in the MapReduce job is failed, it will start from the scratch because there is no DAG. But here is a DAG, right? We have maintained the operations. Like we are having a information of each operation having the information of the next operation, right? So suppose I say this particular operation I have, next operation I know this one, next I know this one. So whenever I got failed anywhere, I will restart from there. So it will be faster. So this is we can say recomputation is a faster. Okay. So here in the Spark, recomputation is faster due to DAG if any particular state of operation got failed anytime, anywhere, anytime, anywhere. Okay. So that is thing is maintained anytime, anywhere. So and so this DAG is maintained. Okay. So there are two things are there: DAG scheduler and one is a task scheduler. Okay. In the architecture. So one architecture what I showed you, that is high level architecture, just like not internal architecture. So when I say Spark internal architecture, so when I say Spark internal architecture, so you are able to see there is a cluster manager, there is a worker, executor, right? But when I say Spark internal architecture, so Spark internally using the DAG scheduler and one is a task scheduler. Okay. So DAG scheduler is basically maintaining the DAG and task scheduler is basically maintain the task. Okay. So DAG scheduler and task scheduler. And one more thing comes in the Spark, some more concept is there. Spark is having the job. So job is a very common term, right? One Spark job can be missed. So this entire thing is a job. When I say these are the entire thing is a job, right? So while reading the data, then flat map, filter, and writing data into file. This is one job. Okay. But I say this job is divided into the number of stages, and stages are divided into the task. Okay. Now we understand what is the stages and what is the task. So stages means when we say this all operations are narrow type. Okay, I will talk about what is the narrow type and what is the broad type transformation. So that is a category of the transformation. Two types of category of the transformation. Okay, so transformation you understand, one form to another form to conversion. One form to another form conversion is transformation, right? What we are calling about like RDT to RDT conversion, right? I say one RDT to another RDT. And this same thing apply on the data frame also. Okay. So because transformation and action, these are common to across the data structure. Okay. So the terms, whatever I'm using here, flat map, filter, same terms will be there in the data frame. But RDD is for unstructured data, right? RDD is basically used for unstructured data, not audio video type data. I'm saying unstructured data means like text file data, the data which is not having a schema. Like if I say this entire data, there is no fixed column. Here are 7 columns are there. Here only 4 columns are there. Here 10 columns are there. So it's a completely unstructured form of the data, this text file. So whenever you are reading a data as a text file, This is called unstructured data, right? But data frame is a tabular representation of data. When you are reading data, from CSV file, JSON file, XML file, Parquet, Avro, ORC, okay, or any SQL database, NoSQL database, okay, NoSQL database, or you can say any other third-party tool like Mongo, Cassandra, anything. So whatever place you are reading data, except this unstructured data, so by default, data will be a data frame. Okay, the data will be read as data frame. Okay, automatically it will be a tabular data. Okay, tabular data. So you know already tabular data means you know that data is having a row and column, rows and columns, right? Okay, but RDD data is the unstructured data, and data we read as a row by row. So row by row transformation we do. So you know there is in the file format we have seen row oriented and the column oriented. So this is the same thing is there, but not exactly same. But the data is row by row is that in the RDD, and the data frame is the tabular representation of the data. Okay. So one I'm saying stages, like two types of transformation I was talking about. One is narrow and another one is a wide transformation. Okay. When I say transformation, so narrow means like map, filter. These are when the data shuffling is not same partition. Okay. So narrow transformation is when the data shuffling is within same partition. Okay. So this kind of transformation is called narrow, and the examples are map, flat map, filter, flat map, filter. These are the narrow. And wide is data shuffling across the partition. So data shuffling across partition, like group by key, reduce by key, join, union. Like here is multiple data set you are combining. Here is only one data set you are filtering, or map or flat map you are doing in the same data set. But you have a multiple data set and you are joining the two data set, right? Two RDDs you can join or two data frame you can join. So your transformation is a wide transformation. So stages means when your narrow transformation happen, so there is no stage change. There is no stage change. The stage will not change. So suppose I say my one stage is created here while reading a CSV, it will remain same stage, but it will not change because there is no wide transformation, narrow transformation. So there is no stage change. But if I say, so if my transformation is a wide transformation, then new stage will be created. So somebody asking you how many stages are there, new stage will be created. Okay. So if I say here in this operation, there is only one stage because this all will be happen in a one. But suppose after this filter, you are doing some join operation. Suppose I'm saying here the same thing, you are applying the join. So when you are applying the join here in middle after filter, you are doing join. So then it is so here is the second stage will come in picture. Second stage will be coming after join. Okay. So you can say in this operation, two stage will be there. Here is a one stage because everything is in the same stage. Okay. I will talk about more on this one. Okay. So this is just you revise this one critical fundamental thing. I will give you one PPT also so that you can understand more clear concept. So installation we have done already or not? Spark installation. Okay. So Spark, it's very simple, just like a scoop. So Spark download, you go, okay, and you download, go here, and here you select the version 3.3.4, and here you select this one, okay, because here it's because Spark is completely on top of the Scala, right? Library Scala, right? So if you are using this one means the Scala version is supporting, and this one is for Scala 2.13. So we are using a Scala 2.12, so we refer this one, okay. So use this one and download this tar file, extract this tar file, and set your Spark home and bin path. So if you set your Spark home and Spark bin path, okay, otherwise I can show to you. So then your Spark will be started, okay. Like you can, your Spark configuration path will be set. So you have to download this tar file here, this tar file you download, extract it, keep it in the software folder, keep it in the software.
Yeah, Ravind, I have a question.
Yes.
Union is not white transformation, right? It's just a union based on the column names. Will union, right?
Union means this like
Transformation, I think.
union is if we check maybe, right, okay, but shuffling, okay, union we can say in sense of like because data is not shuffled, okay,
Yeah.
even though data set are multiple data sets are there, right, okay.
Yeah.
So
And there is a thing called based on the default partitions will get stages, I think.
union is actually shuffling doesn't do, okay, the main concept in the white transformation is shuffling is there, because union is just combining the rows, right? That is a union, right? Suppose I say I have three element in the one RDD and second one has also three elements. So first condition for the union is it should have the same number of elements, right? So that it can be union, right? Suppose I say 5 columns data I have, like, okay, I have a ID, name, age, okay. So when I say the another data set also the same ID, name, age only, right? Then I can do the union of the record. So here shuffling is not needed because we are just adding the rows, right? Just we have to add the data of one data set to another data set, right?
We are
So
just, I think so. Um, when we go for a union by name, we might get an or a union or get the, I mean, different trans. I mean, the
but
way trans.
join, group by key, reduce by key, okay. This is all like why the union is a narrow transformation and intersection is a wide transformation. Okay. See, it is just adding column by column. Suppose I have a one ID, name, age. So ID to ID, I have to add the value, right? I don't need to do any shuffling. But intersection need shuffling, like group by key, reduce by key. These are the other transformations, which are the wide transformations. Okay. So that could be a reason union they have not captured in the wide. But union is not done in the one data set. Union is always done on the two data set, three data set. That meaning is union. Union means combining the data from the various data set to in a single data set. That's the union, right? Intersection also the same thing, right? From various data set to just find the common element, right? That is the intersection. Okay, so once you're okay, I show you my path. Okay, so then you can understand and HRC. So once your Spark, right, you have copied in the software folder. So you can see in my case, Spark is my home Irving software Spark. You can see here. So whatever folder name you keep it, whatever folder name you keep it, Spark 3.2.3, right? And I set it my Spark bin path, right? Once you do this, and you have to use the source command, like you have to use the source -s, right? After this, you just start the Spark hyphen shell. So when you write Spark hyphen shell, it will bring your Scala prompt. This is a Spark Scala shell. So this is a Spark Scala shell. Scala shell. And when you are using this is Spark Scala shell, so you can write a Scala code here. Okay, like I can define the where a equal to x equal to 10. Or Spark, when you print the Spark session, this is Spark session type. I told you, right? The Spark variable is a Spark session. And when you type SC, it's a Spark context variable. Okay. Okay, so both are there. And when you exit, is the function is there. If you write a PySpark, okay, so you will get a PySpark shell, triple greater than sign. So this is the PySpark shell. Okay. So you can test it. You can test it like your once you configure your Spark, just test it your Spark Scala shell or PySpark shell is coming or not. So here you write a Spark, so you will get a Spark session. Okay. So this is Spark session. So we will see first writing a code in the interactive shell, and you can start the small code of example. There is a Spark by example website is there. Spark by example. So here is a all PySpark code is there. PySpark code. PySpark. So PySpark GitHub code. So this one will give you the entire code library. This is the PySpark. So there are many. These are the all data frame, RDD, all examples are there. It is completely mix of the example. Like how to read a CSV file. So this is the CSV file they are reading. Okay. So it's a programming, completely programming. Okay. So we will not do this step because Spark session is already there. Spark session is already there. So we will start writing the code like this, like we are reading a file. So we will write a code like this here, reading a file. We have to give a path. We have to give a correct path because I just copy pasted. So I will show you that how to get a data frame, how to get RDD. Okay. So first you go through the fundamental theory part and start your Spark. Okay. Tomorrow I will show you the RDD and data frame. Okay. If you can go through this code, I'm pinging you. So this entire code base library you can see, especially RDD examples you can start. So there is the RDD examples are here. Okay, so these are all RDD examples, like RDD map examples. Okay. But Python should be, you should know the Python, right? Okay. If you think like, okay, I can cover Python. Otherwise, if you can cover Python simultaneously, I can start the Spark code. Okay. Because basic Python programming, you should know what is Lambda, how to write a list, right? Suppose I want to write a list, right? So square bracket, I write a list. This is a list. Okay. I want to write a tuple, right? So this is square bracket, right? Bracket, I'm writing a tuple, right? And it's a list of tuple. Okay. So list of tuple. So in the square bracket, you have round bracket tuple. So this fundamental collections, right? I told you here in the W3 school, try to understand those, at least collection things is very important. And the loop and functions, while loop, for loop, right? These kind of small practice examples you should use, like how to write a function. So def keyword, I will define a function, right? If I want to pass a parameter in the function, so def function name and pass the parameter. Okay. So whatever parameter you pass it, it will be assigned to the function. Okay. Parameter, function parameter. Okay. and it will print that print line is there, or anything you can write. Okay, so what you want, like you want like I should do this all, or you will be doing parallelly? I should go forward first part. Okay, check that and tomorrow let me know. Okay, I'll cover the way. Okay. Because this Python code is a very self-explanatory code, because mostly I will suggest you small code examples you start writing, then you will get an experience of writing code. Okay, like you try to create a list, print a list, for loop. Okay, how to access the item list indexes, how to remove list items. Okay, and I have my 3 Python videos there. Okay, I gave the playlist, right? I told. Okay, so use that playlist, and or otherwise I will refer those playlist videos. Okay, Python playlist. So you can watch those Python playlist videos. You can refer that. Okay. Okay, so we'll connect tomorrow. Okay. Yeah. Anyone has any question?